Electrons are much farther from the nucleus than the nucleus itself, because electrons occupy quantized wave-like orbitals that spread out over a much larger region, while the nucleus is a tiny, dense core made of protons and neutrons. Think of the atom like a tiny solar system, where the nucleus is a very small, heavy marble at the center, and the electrons are fuzzy clouds orbiting far away. But instead of little balls on fixed tracks, electrons behave like waves that can only stand in certain allowed patterns called orbitals. These allowed patterns set the energies and sizes, so the lowest energy orbital still has the electrons spread out much farther than the nuclear size. And because of the Heisenberg uncertainty idea, you cannot pin down an electron very precisely without giving it a huge uncertainty in momentum, which also prevents it from collapsing into the nucleus. The forces between the positively charged nucleus and negatively charged electrons do pull them in, but quantum rules and the requirement for discrete energy levels mean the electrons form diffuse shells and the nucleus stays compact because protons and neutrons are held together by a much stronger short-range force that operates only at subatomic distances. A common confusion is thinking electrons are tiny hardballs circling the nucleus like planets, and that picture makes people wonder why they are not inside the nucleus. The fix is to remember electrons are described by spread-out wave functions with probabilities, not little spheres, so they naturally occupy larger regions. Another mistake is assuming classical electrostatics alone determines electron position, forgetting that quantization of energy and the uncertainty principle set a minimum spread for bound electrons. Reminding yourself of these quantum rules helps. Some students think the nucleus could be the same size if you increased attraction, but the nucleus size is governed by nuclear forces and particle structure, so changing electron behavior does not shrink the nucleus. For more videos and resources on this topic, visit www.gumballdegree.com.